In this section, we're going to review the file3.pcapng. So if you haven't opened Wireshark already, please do, and open the file3.pcapng capture file, and you can follow along, or you can watch me and then work on it after you see me do it. So once you open the file, we want to see what's contained within. Now we can deploy a number of methods of doing this. As we see, there's 24,625 packets in this packet capture. We see here in packet 1, we have an ARP reply. And then we see in packet number 2, we have another ARP reply. The problem is, take a look at packet 1 and packet 2. Do you see anything strange? They have the same MAC address, but they have different IP addresses. That cannot happen. And even the Wireshark tool, the newer version, will show you this, as you see right here, with duplicate use of this IP address detected. So now, what is this? This is two machines on the network having the same MAC or physical address. So when you think about that, where's the data going to go? Is it going to go to the first MAC address machine or the other machine? And the problem is it's not defined because this is a duplicate MAC address on the network. And in this case, this MAC address that's pointing to these two machines is an attacker. And what they're doing is they're setting up a technique called ARP spoofing or ARP poisoning. And what they're doing is they're pretending to be both of these machines. And that is the characteristic of a man-in-the-middle attack. And that's exactly what this is. This is an attack or a man-in-the-middle attack against these two machines. After the man-in-the-middle attack, we can see there are a lot of resets in the packet capture. So as you scroll down in the packet capture, you see a lot of resets. See these resets and then resets? More and more resets. Now, you're seeing a lot of send packets followed by resets. Now, if you remember, we specifically stated that resets are an abnormal close. That means something's taking place on the network. There's concern, so we shouldn't see a lot of these resets. Remember, resets are an indication of ports that are closed. So an attacker, if they go look for ports being open, any port that's closed is going to respond with a reset. So because of this, this looks like indications of what we call a port scan. A port scan is, again, that attacker connecting to as many ports as they can to see if they get a response. The response they're looking for is a SYN-ACK, because the SYN-ACK will do what? The SYN-ACK identifies the ports open. Remember, no matter how good a hacker is, they have to have the port open or a door into the machine to attack it. All right? So we see a lot of port scanning going on. Reality is that port scanning is quite common. From our analysis point of view, we're concerned with the data. So as you may recall from the slides, we have the push flag that represents data. Now remember our power of filter. So now we can actually put this power of filtering to good use and apply it to make this packet capture easier to disseminate and easier to analyze. So now what we're going to do is we're going to enter a filter, tcp.flags.push equals 1. So what that says is if the push flag is set, display the packet. So now all we do is click the blue arrow and we apply our filter. These are the only packets with data in them. And you see here this packet, fin, push, and urgent. You remember what that is? That fin, push, and urgent is that signature that we showed you in the slide of an XMIS scan using the Nmap tool. So now we've got indications of an XMIS scan. Not a big revelation. So an XMIS scan is just a type of port scanning. So now if we go to packet 10.295 right here, we see over here in the info section that a version of bind was returned. Well, what is bind? Bind is Berkeley Internet Name Domain. It's what does that DNS or domain name server for the internet. And as you remember, DNS was how we mapped the name to a machine from a human readable form to machine readable form. So now, using our techniques we used, if we right click this, we'll click follow, TCP stream. Right there tells us in blue the server responded with its bind or Berkeley Internet Name Domain version of DNS mask 2.39. So now the attacker has determined that in this packet capture, this target has DNS mask 2.39 that's operating as its domain name server. So that's a concern. So if we clear that filter, close out, and we go back to our other filter, so we can click on our drop down. We go back to our data filter. The wonderful power of filtering in Wireshark, again, is looking at the data. Now, we just followed the string, but you can also see down in here, this is the version.bind down here. So what we can do is we can just arrow down. As I said, everybody has different preferences. But as you see here, now I see this DNS mask -2.39. And I go down and I look at push. Remember, this is all data that's been received. Now, this push is HTTP type traffic because it has this GET request here, as you see in the data window. So this goes to a web server. So let's see if anything has been uncovered by the attacker. And in this case, we do have an Apache 1.3.37 running on Unix. It's using Mod Secure Sockets Layer 2.8.28, Open Secure Sockets Layer 0.9.AE. Guess what? That is leaking too much information. And in fact, all that information that's leaked right there could lead to potential attack vectors for an attacker. So just by following the process that we've covered throughout the course, you've now identified a weak area and an area that could be attacked for either your own network or any network you're hired to monitor or take a look at. That's the power of understanding protocol analysis with Wireshark. You have the tools now. Now you know how to do a number of different types of protocol analysis, and we're going to build this skills in the final section. Next up, we will explore another capture file. You'll review more types of attacks using the process we've enhanced throughout the course. This is to give you your skills and now apply those skills so you get more experience. By learning what we've shown you so far, you can apply those skills and do a multitude of things as we've already discussed. And that's what we're going to do next.